speaking of those satellites, all 24 of them are safely enclosed inside of the 17-foot diameter payload fairing, which is the pointed structure on the very top of the rocket. This protects the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we no longer need them, so we will jettison the fairing as the second stage continues on its journey to orbit. We will be attempting to recover the fairing pieces tonight with our recovery vessel, Miss Tree, formerly known as Mr. Steven. Our hope is to catch one of the fairing pieces in the ship's nets and recover the other piece from the water. If we are not successful with our catch attempt, Miss Tree will recover both pieces from the water. Let's check in on how the countdown is going.
It's T-minus 14 minutes, 10 seconds and counting down. Good evening. I'm John Isberger, the Falcon Principal Integration Engineer at SpaceX. Now we are at T-minus 14 minutes from the launch of the Falcon Heavy, and all systems are go for launch on the half hour. Falcon Heavy rolled out to the pad with the payload 27 hours ago and went vertical about 7 hours later. Now we did have a ground hydraulic issue early in the count, but it was fixed, and currently everything is go. We cleared the pad deck at T-minus 9 hours to begin hazardous operations. And just before we began the webcast, the SpaceX launch director pulled the 9 members of the launch team. You can see the firing room at Kennedy Space Center. We pulled the team, got to go for propellant loading and launch. Now we're currently loading propellant on all 3 first stage boosters and the second stage. Now we load 2 propellants on the Falcon Heavy. One is liquid oxygen called LOX. No oxygen is in space to support combustion, so we have to bring our own. We chill it to get it as dense as we can in order to maximize how much we load. The second propellant is our fuel, RP1. That's essentially a purified kerosene. Now these 2 propellants have a long history of usage. The Saturn V first stage, flown from this very pad on the moon missions 50 years ago, used LOX and kerosene. Now for the satellites on tonight's flight, everything is go. The last transfer to internal power is coming up in just half a minute. Other than that, the spacecraft teams here at the Cape are monitoring data as we proceed to T0. And I expect a lot of satellite builders and operators are anticipating getting data from space with a lot of enthusiasm. Now we're launching out of the Eastern Range, supported by Cape Canaveral Air Force Station. The range is currently go. They're prepared to support today's mission. They're making sure that the sea space, the airspace is cleared. No one's nearby to get in the way of tonight's launch. They're also releasing balloons, which brings up the question of how's the weather? The good news is the weather is looking very good. Ground level winds are acceptable. Upper altitude winds are also acceptable. Now, as Alex mentioned, we started the day with a 4-hour window. However, now that we are into LOX loading, we don't have the ability to hold the countdown. Falcon Heavy is 3 rockets counting down at the same time. We need so much liquid oxygen that we would have to scrub tonight in order to use the backup date tomorrow at the same opening of the window time, 11:30 p.m. Eastern. Now, if you followed the SpaceX webcast in the past, you've probably heard me remind everyone that launch is hard. Well, that goes double tonight, as we're going to fly the most demanding mission profile for a Falcon rocket ever. So the SpaceX team has their conservative dial set at 11 and stands ready to take time to look into anything out of the norm. Now, as the energy from the team gathering below me outside of the control center is growing, we are go at T-minus 10 minutes and 51 seconds.
As we mentioned earlier, tonight's launch is for the U.S. Air Force and is a rideshare mission with 24 satellites. The mission involves the largest number of government agencies we've had as mission partners, including the Air Force, the Naval Academy, NASA, NOAA, and the Taiwan Space Agency. The specific agency inside the Air Force responsible for overseeing tonight's mission is the Space and Missile Systems Center, or SMC. Let's get some more details about what the agency does and is responsible for.
What is SMC? SMC stands for Space and Missile Systems Center, but that's just a name. Who we are, what we do, it's much more than just a name. We're the dedicated men and women who develop, acquire, field and sustain cutting-edge space experiments and operational satellites. Our mission: deliver resilient and affordable space capabilities. What does that mean? It means we enhance military communication systems, acquire next-generation GPS satellites, develop advanced remote sensing and service capabilities, field cutting-edge rocket systems, modernize the United States satellite control structure, create never-before-seen technology, and deliver sustained, unrivaled space superiority for our nation. Let's face it, the world's changing. Along with it, SMC is changing to ensure the United States remains the vanguard of space capability and scientific understanding. We dubbed our aggressive and innovative new approach to the way we work SMC 2.0. That means speed, to quickly implement the best solutions to new problems. Partnerships, to forge the relationships necessary for the mutual benefit of the U.S. and our international allies. Innovation, to capitalize on the most advanced cutting-edge technology in the world. Culture, to inspire the necessary risk-taking that will propel us into the future. And enterprise, to share our vision of accelerated and affordable space systems for the Department of Defense. Initially founded in 1954 to develop the first intercontinental ballistic missile, SMC has produced unprecedented and unparalleled national defense space technology for over 60 years. During this time, we've been called upon to support manned space, anti-satellite, and missile defense programs while continuously increasing our space capability. That's where we came from. But a more important question is, where are we going? Humans have always been explorers. We venture to discover that which is unknown. At SMC, we push the boundaries of the known and fight every single day to enhance our technological capabilities, launching past the limits of the sky. We are the pathfinders to the high frontier, and we are building the future of space.
The SpaceX team continues to count down for launch for the nighttime launch of Falcon Heavy. I remember watching the night launch of Saturn V on the Apollo 17 mission in December 1972, and it turned night into day. We're expecting the same tonight from 27 Merlin engines. We're currently at T-minus 7 minutes, 28 seconds and counting. Fuel loading is continuing. We're about to wrap up fuel loading on the 3 first-stage boosters over the next minute. Liquid oxygen loading is continuing. That'll wrap up between 3 and 2 minutes before liftoff on all the stages. We've had the report the last satellite has gone on internal power just a moment ago. Everything's looking good on the satellites. Now, a major activity coming up here in another 2.5 minutes is retract of the strongback. We'll see the clamps open up around the second stage. The strongback will recline about 2 degrees in preparation for launch. We're also just inside T-minus 7 minutes. We've begun chilling in the 27 Merlin 1D engines. Now, a lot's going to happen in the first 4 minutes of flight of the Falcon Heavy. We'll first light the 2 side boosters and then the center core. The flight computer on Falcon Heavy will check the power on all the engines, then command a release from the ground hold downs at T0, so we lift off at T-minus 0. Right after we lift off, we're at full power of over 5.1 million pounds of thrust. 40 seconds into flight, we decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to power on the 2 side boosters. We now are 2 minutes into flight, and we're again reducing thrust on the 2 side boosters. This time it's to decrease forces on the rocket structure, especially that structure that holds the side boosters to the center core. The acceleration is building every second as we burn propellant and we're lightening the rocket. So we need to throttle down the side boosters by physically turning off engines to keep the loads below the maximum allowable. 2.5 minutes into flight, we fully turn off the side boosters, called BECO, Booster Engine Cutoff. Then we'll use high-pressure gas separation system that's mounted on the top and bottom of the center core. That'll unlock the 2 side boosters and push them away. Now, once we're clear of the side boosters, the center core will throttle up to full power and burn another minute. Finally, at just past 3.5 minutes after liftoff, the center core shuts down, main engine cutoff, and the second stage separates. Now, from this point on, It's like a Falcon 9 mission, other than we do happen to have 3 first-stage rockets returning to Earth at both Cape Canaveral and the drone ship. Meanwhile, on the way into orbit, the fairing will separate. The second stage engine will undergo a series of 4 burns, eventually delivering all 24 satellites to their intended orbits. Now, it's a demanding sequence of events for the Falcon Heavy tonight. But from this point on, everything is looking good. We're at 4.5 minutes. We're getting ready to recline the strongback. So let's watch and listen to the final countdown.
Strongback starting to retract. And negative Y LOX load is closed out. And positive Y LOX load is closed out. Strongback lower is closed out. And stage 1 LOX load is closed out. Vehicles on internal power. And stage 2 LOX load is closed out.
Ground gas close, that's complete.
And the vehicle is in startup.
This is the mission director. Go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Vehicles pitching downrange.
T plus 25 seconds into flight under the thrust of over 5 million pounds. Falcon Heavy is headed to space. We're getting ready to throttle down for passing through the period of maximum dynamic pressure.
Max
We've
Q.
heard call out of throttle bucket
telemetry
for
nominal.
side core. We're through max Q.
Vehicle is supersonic.
Everything continuing to look good on the Merlin 1D engines. We're throttling back up on the side boosters to full power. A minute 15 seconds into flight. Performance looks nominal. Currently, the next event coming up in about 2 minutes. We'll hear call out of chill-in of the MVAC-D engine. That allows liquid oxygen to the top of the turbo pump to get the second stage engine ready to chill for ignition in just a couple of minutes. We're 2 minutes into flight. We've begun to decrease thrust on the side boosters to minimize acceleration and loads on the Falcon Heavy structure. We've turned off one engine on each of the side boosters to decrease that load. Now our next major event coming up here in about 10 seconds, shutdown and separation of the side boosters. The view should be the side booster cameras on two sides and the center core in the middle.
Booster shutdown.
Booster separation confirmed.
Over the cheering in the background, it's going on midnight, but a lot of people here at SpaceX. Side boosters have separated. They're getting ready for their burn back to Cape Canaveral. You can see on the left and right views, the side boosters have ignited. The center core continues under full power. Everything looking good on the Falcon Heavy. Next event coming up in about 15 seconds will be shutdown of the center core, followed by stage separation and ignition of the second stage engine. Good views of the two side boosters under the thrust of 3 engines each, slowing down their velocity and coming back towards Cape Canaveral. We have shutdown on the center core.
Go. Stage separation confirmed.
We have successful separation and ignition. We're coming up on shutdown of the two side boosters.
Side booster boost back shutdown.
And we've heard the call out side booster boost back shutdown. The center core, you can see, is not doing a boost back. It's headed downrange to the drone ship. Here comes fairing separation.
Cross ranger nominal. Fairing separation confirmed.
We have confirmation of the payload fairing separation. So far, 4 minutes, 17 seconds into flight. Second stage looking good, headed to low Earth orbit, carrying the 24 satellites. The side boosters have done their first boon, coming back to Cape Canaveral. The center core has separated and is beginning its long coast downrange to the drone ship in the Atlantic Ocean. So at 4 minutes, 35 seconds and counting, everything looking good on Falcon Heavy.
Now those side boosters are making their way back. Their grid fins on all 3 boosters should be deployed, and those are help guiding them to their landing zones. As a reminder, today we will be attempting to recover all 3 of these first stages, and all 3 boosters are currently making their way home. In just a few minutes, the side boosters will execute an entry burn followed by a landing burn, and the center core will complete the same burns just a few minutes later. Both burns are used to slow the stage's speed down rapidly before landing.
At the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land at our side-by-side landing pads. The center core is going too fast to efficiently return to the Cape, so we're using our autonomous drone ship, Of Course I Still Love You, as we mentioned earlier. As a reminder, our drone ship is positioned twice as far offshore than normal, so we may not get visuals of landing tonight. Also coming up in a few minutes will be the call out for second engine cutoff. So coming up in about a minute here, we're going to look for that side booster reentry burn to begin. Shortly after that, that should end about 20 seconds later. You can see both of those boosters on the infrared camera on the left side of your screen. Again, about 30 seconds until we expect those side boosters entry burn to begin. So keep an eye on the left side of your screen. In about 10 seconds, we should see those side boosters reignite for their entry burn.
Side booster entry burn startup.
And we have confirmation that the entry burn has begun. And in about 15 seconds from now, we expect that to end. Oh, wow. You hear the crowd cheer behind me. And that entry burn has completed. Note that second engine cutoff and the center core will be landing almost at the same time. So we're going to have a few events in succession at about T plus 8 minutes and 21 seconds.
Both side booster FTS is safed. Stage 2 FTS is safe. And terminal guidance.
In about 20 seconds, we're going to look for that side booster landing burn to begin on both boosters.
Side boosters transonic.
About 10 seconds away.
Side booster landing burn startup.
We've heard the call out for side booster landing burn startup, and there you see it on your screen. See it coming towards our 2 landing pads. See those landing legs deployed. Incredible.
Side boosters are successfully landed. Landing operators moving to procedural.
Confirmed side booster landing. What an iconic view. We've also, at the same time, I believe we've had second engine cutoff at the same time. As we mentioned earlier, the center core entry and landing is going to be risky. During entry, it'll face more heating and dynamic pressure than we've ever experienced on Falcon 9 or Heavy flight before. Why, you ask? Because we have to lift the second stage higher and faster than other Falcon Heavy flights in order to have enough performance in it to execute 4 burns into all the different orbits. So coming up at T plus 9 minutes and 39 seconds, we should see the center core entry burn ending.
Center core entry burn.
Oh, we have the confirmation. Looks like that was the confirmation for it to begin. So we're a little bit off the timeline.
Center core entry burn shut down.
And we had just heard the confirmation that center core entry burn has shut down. And now that the entry burn is complete, the center core is moving back about 20% faster than it was at the end of the Falcon Heavy 2 Arabsat entry burn.
First stage Cape LOS expected.
Now we're coming up, we're just about a minute away from that center core landing burn beginning, and as we've been mentioning, this will be the most difficult landing that we've had to date. This will be a 3-engine burn. That center engine will start up first, and then 2 outer engines will start up as well for that landing burn. Now we're just 30 seconds away from that center core landing. And it's no surprise that we do not have a live view of that center core as it's coming down, but it looks like we got a live view of the drone ship there. Of course, I still love you. If you're just now tuning in, we're just about 10 seconds away from that center core landing burn beginning.
Stage 1 landing burn has started.
And we have confirmation that the center core landing burn has begun. You can see that coming down on Of Course I Still Love You.
Center core landing are deployed.
Got a pretty good view. And as you can see on our screen, it looks like our center core did not make it on our drone ship, Of Course I Still Love You tonight. Again, as we've been mentioning, this was the most challenging landing that we've had to date. And this is our secondary mission. So our primary mission, we just heard the call out for a good orbit of our second stage. So we are actually just moments away from our first deployment of the evening for Oculus ASR, which was developed by students at Michigan Technological University. We will be passing beyond the Bermuda ground station, so there is a chance that telemetry may cut out a few seconds before deployment, in which case we won't be able to see the satellite actually deploy on camera or get confirmation of a successful deployment until telemetry is restored. Now we're just about 30 seconds away from that deployment, so we'll listen into the nets for that confirmation. Looks like we still have that live view. Might have a chance to see this deployment live on camera. Again, we are waiting for the Oculus satellite deployment. And as we expected, looks like we lost that live view. So we will wait to get some confirmation of that deployment, and we will update you guys in a few minutes later on in the webcast. We are now in between ground stations for the next few minutes with nothing to see. So we are going to take a quick break, but we will be leaving you with an animation that shows you where we are throughout the coast phase. We will be back around T+20 minutes for our next set of deployments. And it's worth noting that since we won't acquire ground station coverage again until T+21 minutes, we are going to miss that first P-Pod 1 CubeSat deployment. See you back here in about 6 minutes.
Welcome back to the webcast for the STP-2 Falcon Heavy mission. We're T plus 20 minutes and 7 seconds and counting. Right now, as we left the webcast, we were waiting to see the Oculus satellite deploy. We didn't have confirmation when we lost signal over Bermuda. That was normal, losing signal. You do it when you pass beyond line of sight. We also should have had a minute and a half or so ago the first P-Pod #1 open up and deploy 2 CubeSats for the Naval Research Laboratory. But we're waiting until we reacquire signal over the Ascension Island tracking station around the equator in the middle of the Atlantic so that we can understand whether or not the Oculus satellite deployed and how P-Pod 1 deployed also. While we're waiting for acquisition of signal from Ascension, just to recap, we had a great launch of Falcon Heavy. The 2 side boosters did their choreographed landing at landing zones 1 and 2. The center core, as you heard from the people and may have seen a shot on the screen, missed the drone ship. We knew this was going to be the toughest reentry. We are getting data back, so the team will understand over the next hours and days how things have gone. It looks like now we're beginning to reacquire signal over Ascension Island. We're waiting to hear a call out how the first 2 satellite deploys have gone. It appears we have confirmation that the Oculus satellite was separated and P-Pod #1 opened up, deploying the Naval Research Laboratory satellites. There's a view from space, and if you remember the view just before we left, on the bottom left was the Oculus satellite, had a white coloring to it, and it's no longer there. Now we're going to cover the last of the 8 P-Pod satellites that are coming up for deployment, and that's going to take about 30 minutes to get through this sequence. The next deployment comes up just before T plus 25 minutes. Now these 8 deployers will open and they'll release 11 satellites. Now if you've watched our coverage from other launches like Iridium, you know that the 1 camera we have on top of the payload attach fitting cannot see all sides of the dispenser holding the satellites. Because of the positioning right there, as you see on your screen, of the 1 camera, we won't be able to see all of the CubeSat deployments today. In particular, the next 3 P-Pods, 2, 3, and 4 on the back side, we won't be able to pick those up. However, as the second stage does maneuver in orbit, in the sunlight, we might be able to pick up a glint of the sun off of the CubeSats as they move away from the second stage. Now the next deployment, coming up just before 25 minutes, is known as Falcon Sat 7. This is an optical telescope for the United States Air Force Academy. The CubeSat, when it is ejected, will eventually deploy a rigid boom that holds a membrane that acts like a lens in a telescope. And once that membrane is rigid, it will allow imaging of the sun. So this is a deployable optical telescope for the Air Force Academy. However, as I said, we won't be able to see it. We'll have to wait for call out to confirm the separation.
Gabon acquisition of signal.
We've heard a call out. Gabon has acquisition of signal. As we are approaching the African coastline, the next ground station beyond Ascension Island is picking up the signal from Falcon Heavy second stage. Coming up on deployment in about 5 seconds.
P-Pod 2 deploy confirmed.
And there's the call out from the avionics engineer. Always a little bit tense as you're waiting for them to confirm that the signal indicates that the door is open. Inside of each of the deployers is a spring that pushes out the CubeSats. And what we have is confirmation that the Air Force Academy deployable optical telescope should be in orbit on its own now. Now we've got about 235 seconds until we get to the next deployment.